Hello friends, today we'll see test for amines. These are the tests to distinguish between aliphatic and aromatic amine, as well as we can distinguish primary, secondary and tertiary amine by these tests. So first test in this category is Hencebug test. So in Hencebug test, amines are treated with Hencebug reagent. Hencebug reagent is benzene sulfonyl chloride, and after treating amines with that, it is then shaken with aqueous KOH, which is a strong base. With Hencebug test, primary, secondary and tertiary amines react in different ways. So by using Hencebug test, we can distinguish between primary, secondary and tertiary amine. So let's see the reaction for primary amine. Primary amine gives a clear solution which on acidification gives a soluble N-alkyl benzene sulfonamide. So this one is Hencebug reagent benzene sulfonyl chloride, benzene ring COO, benzene ring SOO and Cl. Primary amine is RNH2. So here one of the hydrogen is removed with chlorine, HCl is removed, and what we get, N-alkyl benzene sulfonamide, which is soluble in base, which is soluble in KOH, and that solubility reaction is given here when it is treated with KOH. This NH hydrogen which is on nitrogen is accepted by base KOH, and N minus potassium salt is obtained. So this is soluble in water, will get clear solution. So this is the test for primary amines with Hencebug reagent. What happens when Hencebug reagent is treated with secondary amine? So secondary amine gives an insoluble NN dialkyl benzene. NN dialkyl benzene means tertiary amine is obtained. Okay, and N1 is secondary. So from primary, secondary amine is obtained using benzene sulfonyl chloride. Similarly, secondary amine when treated with this Hencebug reagent, NN dialkyl benzene sulfonamide is obtained, which remains unaffected on addition of acid. So see the reaction, Hencebug reagent benzene sulfonyl chloride plus secondary amide R2NH, and this H goes with Cl, HCl will go out, and NN dialkyl benzene sulfonamide is obtained, which is insoluble in KOH because there is no free hydrogen. As you see the product, there is no free hydrogen, so it will not react with base KOH. What is the role of base? Base are the one which accept proton. So no proton is here. Therefore, it will not dissolve in KOH. In case of the earlier one, N-alkyl benzene sulfonamide, H was there on nitrogen. So KOH accept that H, and therefore it becomes soluble in KOH. Here, because of no hydrogen or nitrogen, it is insoluble in KOH. Tertiary amine do not react with Hencebug reagent because they don't have hydrogen attached to nitrogen. So at the starting stage only, okay, CS3 thrice N, trimethylamine or triethylamine, they don't have hydrogen directly attached to nitrogen, and therefore they do not give Hencebug reagent test. So that's how we can separate primary, we can distinguish primary, secondary and tertiary amines. Primary amines form soluble salt, secondary amines forms insoluble, is insoluble, and tertiary do not react only. Next is isocyanide test. So isocyanide test is also known as carbylamine test. Primary amines, both aliphatic and aromatic. Aliphatic means chain amines, and aromatic means which are functional group is directly attached to benzene. So primary amines react with chloroform in presence of alcoholic KOH to form a foul smelling carbylamine. Secondary and tertiary amines do not give this test. So if you want to distinguish primary amine from secondary and tertiary amine, we can use this test, carbylamine test, or it is also known as isocyanide test. And now see the reaction. Primary amine RNH2 is treated with CHCl3 chloroform plus alcoholic KOH. In presence of heating, it will give alkyl isocyanide. And on reaction side, hydrogen, oxygen is there, so we have written water. What is left? K and Cl is left, so other byproduct is KCl. So one reaction is given of that: aniline plus chloroform, aromatic amine is aniline, chloroform plus KOH, it will give phenyl isocyanide. Instead of NH2 we have to write NC now, because that isocyanide is obtained. And water is there, hydrogen, oxygen on reactant side, so therefore product side water is written, as well as KCl. So understood this isocyanide test. It is used to distinguish between primary amines with secondary and tertiary. Primary amines only give isocyanate test, secondary and tertiary do not give this test. And last test is Azodite test. Azodite test is used to distinguish between aliphatic amines and aromatic amines. So Azodite test is given by aromatic primary amines only with diazonium salt, NaNO2 and HCl. Okay, and temperature for that formation of diazonium chloride is 0 to 5 degrees Celsius or 273 to 278 Kelvin. So aniline plus NaNO2 gives in the presence of NaNO2 HCl at temperature 273 to 278 Kelvin, that is 0 to 5 degrees Celsius, give benzene diazonium chloride, that is diazonium salt. So good living group is obtained, benzene diazonium salt, plus byproduct is water. When this benzene diazonium salt is treated with beta naphthol or 2-naphthol, so because of electron donating OH group, coupling occurs. Here NaOH is used as catalyst. Dilute NaOH, pH should be between 9 to 10, and this product is obtained. In coupling reaction, N2 is not removed, and that is all because of electron donating OH. So benzene ring attached to N double bond N, then we have to write this 2-naphthol. So 2-phenyl azo 2-naphthol is obtained. It is known as orange dye. So orange color is obtained from this dye, therefore it is known as orange dye. 2-phenyl azo 2-naphthol. So aromatic amine gives this test, whereas aliphatic primary amines under these conditions, under the same conditions, aliphatic amines give off nitrogen gas, and if N2 goes out, no coupling will take place, and they will form primary alcohol, which remains in the solution, and solution becomes clear. So see RNH2, instead of aromatic amine aniline, they have used RNH2, that is primary amine. It could be CS3NH2, methanamine or ethanamine or so on. Same conditions, NaNO2 HCl, 273 Kelvin to 278 Kelvin, that is 0 to 5 degrees Celsius. It gives alcohol, primary alcohol, nitrogen gas is liberated, and water is the other byproduct. So one example is given. So that's how we can distinguish between aliphatic and aromatic primary amines. Aromatic primary amines give azodite test, while aliphatic primary amines do not give azodite test. So these are the tests to distinguish amines. Thank you for watching the video.